Pileggi Technical Services, your computers and electronics concierge service.
Hello and welcome back. Today we're going to be building the Super Stereo Ear from Velleman. This is model number MK136. I got this at my local Radio Shack, which I think is closing because the receipt said the return was supposed to be to the end of the month, and I think that's when they're actually closing. But there's no other signs in the store saying that except for this and some other pieces being on 50% clearance, which is why I bought it. This is actually a pretty cool kit. It tells you that it's a stereo audio amplifier, boosts sounds 50 times. Great for the hearing impaired, example when watching TV, as a gadget science project with volume control and on-off switch. It runs on 3 1.5 volt AA batteries, which of course are not included, but what do you expect? And it's made in Hong Kong. So I've already taken the stuff out of the bag just to kind of see what was inside of it, but let's open this up. And this is actually my first kit from Velleman, but I have seen these before. It's nice that they give you all the instructions on how to build this. Let's see if the camera can pick this up clearly. It's pretty simple. You just follow the instructions from 1 till 12 over here, and it even gives you a nice schematic down here at the end to explain how the unit works, which is pretty cool. It uses a NE5532 tool, which is a dual low noise op amp, and that allows this to work. It's pretty simple. There's just two electric microphones over here, and they're arranged in a stereo setting. I have read online that the microphone jack is reversed on this, but that's fixed simply by just flipping the board the other way around when you get it into its final case, if you build it in one. So this would actually not be the top of the board. You'd want this to be the bottom of the board. You'd be looking at the batteries. But anyway, the finished project's going to have a volume knob over here, an LED indicator switch, an LED indicator light, and a switch. Also, what's nice about this kit is they give you the socket to put the chip into, and it's basically simple, just a simple IC with a bunch of passive components around there. Jacks on the side over here, and I already looked at this. There's an interesting pin configuration over here where you have to solder these pins in, and then it looks like you connect the microphones right to those pins. So that's going to be a little bit of a challenge, I think, but let's get started on this. I like that they give you the color codes for the resistors. I'm not the best with that. I have a little cheat sheet that helps me out with that. And I actually have a good computer program. Electronics 2000 is the place you can download it from. It's electronics assistant software. I'll actually put a link to that in the description. That helps out a lot for finding these resistor codes. But it tells you here that R1 and R2 is a 10K resistor, which is brown, black, and orange. So I'm going to look for that in the boxes over here. I like to get all the parts out first. It kind of helps me. It's like making a cake or doing anything with recipes or food or anything like that where you need all the little bits and pieces out first. You know, it's best to weigh all the ingredients out before you're cooking than it is to do it during cooking. It just makes it easier. So I'm just putting all these components out. Luckily, they give you, if you need 4, they keep the 4 together, so you kind of get an idea what's what there. These are some electrolytic capacitors, which of course are polarity sensitive. We have to watch out for that when we put this together. I'm just going to line all these up. We'll worry about which ones they are, when we get to it. I have no practice doing this on camera. This is actually the first time I've done one of these on camera, so this is going to be challenging in a few different ways. Now, I don't have an anti-static mat here, and the reason for that is I'm actually on a bare floor in my bare feet. So this little chip has not that much of a chance, in my opinion, of getting shocked. Excuse me while I move the camera here. And I'll just dump these out here. Okay, here's all the little components. Here's that little pin. It's a little short pin. I don't know if I can get the camera in on this or not. I'm actually going to try the macro lens I have in this camera when I get to the actual soldering of this, but these are all the components. There's a couple small, these are some ceramic capacitors. There's the rest of the resistors. There's some hardware here to hook up the battery case. Of course, you have your PCB. It's just a single-sided PCB. A little solder mask on one side. If I can get a close-up of that, that's pretty good. That's the back side with the exposed, not pre-tinned, it's just a bare copper. So, I guess this would constitute as a lead-free board, since there's nothing pre-tinned on it, which is kind of good. I don't like that lead-free stuff that they use, that, you know, if you have to like take something apart that's already soldered with lead-free solder, it's a real nightmare to me. It's hard to get off. It just goops up. It doesn't wet nice. I like the good old-fashioned lead solder. It's just me. But I have my trusty old soldering pen set up over here. This thing's pretty battle-hardened. I got this from Parts Express. I don't think they sell it anymore. This is actually the second one. This is a homemade little cover I made, because this actually gets kind of warm right here. You can see where it's kind of melting the plastic. I'm not sure why that component does that. I think it's a choke. I'm not sure exactly what component that is right there. You can see the blinking light. This is actually, I believe, a pulse width modulated iron. There's 4 leads that go to the tip. I'm assuming one of them's, you know, temperature sensor of some sort, and kind of reminds me of like a computer fan setup with the, you know, 4 pins. I'm assuming 2 of them are for the heater though. But this thing's an old trusty. I have it set, you know, just about 350 degrees centigrade. So this thing's just been warmed up and plugged over here, and like I said, this thing's battle hardened. I've used this thing a ton. Tip is, you know, it's in good shape, I think. I mean, here's I use a lot of homemade stuff here. This is actually a dollar store Brillo pad. This is cheap copper. They had this in copper and stainless steel, or so they say it is, but I just have it mounted in the top of a this is actually a rolling rock container, a tall boy, and I have it just mounted in there, and you could just jam the thing right in it, and it cleans it up pretty nice. And you see it's all nice and shiny again. I use this. I have 2 of these. I have one mounted in my shed on the wall. This was actually mounted in a little box. See, it's all hot glued in there, but I do have a vent in the corner. It's sitting over there. It's on low power right now. I'm going to turn that thing on high power too in a second here. It's actually an old computer fan. I have a video on this that I did. I'll also put a link to that in the description. And well, there's not much to this. I'm just going to go ahead and start getting everything set up. Push this to the side. I got some solder over here. I think this is the regular 6040 stuff, again from Radio Shack. It's just easier just to pick this stuff up. I got some stuff at the very end over here. It's got the it's got this silver in it. It's a really good solder. I like the silver stuff, but I use it for more like audio grade stuff. This is, you know, yeah, it's an audio circuit, but certainly not audiophile stuff. And this is just some loose wire. Again, this is a little spool that I built, just kind of custom for here. And then of course you got good old helping hands. So I'm going to actually set this board up in the helping hands. And this is what's going to help us get this installation, this project going quickly. Populate this. Now, speaking of populating, the first thing you want to do when you do these boards is the resistors or any of the components that are going to lie low to the board. That's going to make this a lot easier. So bear with me while I get this helping hands set up. I must have ratcheted it down really tight last time I used it. I also found the magnifying lens. I had to put it aside. Now I found it and I decided to put it back on the unit. tighten this up last time, boy. Oof. Okay. Now let me see if I can pause this video here and put on the macro lens and zoom in a little bit and see if this can pick up what I'm going to do a little better. And I'll be right with you. Alright, and we're back, and I think this is going to work rather well. We have my macro lens on here. We have the helping hand set up. We're zoomed in a little bit. Got my tripod set up. I think it's going to work well. So like I said, the first thing we're going to try to do here is get these resistors mounted. And looking at R1 and R2, they're 10K resistors, which the handy book to the side over here tells me is brown, black, orange. So if you look, I have the brown, black, orange resistor right there. And I need two of them. There's the other one. Again, resistors are non-polarity sensitive, so this does not matter which direction these go. I myself, I like to have them all facing the same direction just for aesthetics. It's just me. It's not necessary. So I'm going to try to make all the gold stripes face the same direction, so all the resistors line up this way. The gold stripe will be on this end, and the other ones will be on the other end facing, you know, that way, I guess you could say. So that's the way I'm going to do it. So R2's down the bottom here. R1 is, I'll be getting screened at, standing right in front of you there. Right here, okay. So I'm just going to get these in, and you can pre-bend them. Some people like to do that. I like to do it my way, which is just put them in, and then I'm just going to bend the leads in the back just a little bit, just to hold it in place. And I'm going to do that with the rest of these resistors. So R2 is over here. And again, like I said, it doesn't matter which way they face. I just want to go my own way with them. Alright. Next one we have is R3 through 6, which is the 220, which is red, red, yellow. Red, red, yellow. So that's, like I said, 3 through 6. Six, 4, 3, 5. There's 3. There's 5. There's 6. And here's 4. And again, we're just going to bend the leads in the back. We're just going to bend out of the way. I'll show you what they look like on the other side. Then we have R7 and 8, which is what they call an 8E2, which is actually 8.2 ohms. Now, there's a reason why they use the E, or sometimes they use an R, and it's because on certain machines the period doesn't come up right, so they use a letter instead to represent the decimal point. So E is the decimal point in this one, so it's 8E2. So I'm going to go ahead, that one's the gray, red, gold. So I need to find 2 gray, red, gold. And here's the gray, red, gold. So I'm going to put those in. 7 and 8 are conveniently located right next to each other here. Oh, and you see I already went against my code. Said I wanted to put them with the goal facing the other direction, and I missed these two. Again, it doesn't matter. This is just me being a little OCD here, but I don't know. It makes the final project look a little nicer, I guess. And then we have the R9 through 13, which is the 1K, which is brown, black, red. There's all of them. So 9 through 13. 9's right here. I got my fan in the background on to suck out any fumes that there might be in the room. There's also a ceiling fan on, so it kind of works against it a little bit, but it's pretty powerful, so it does suck everything out in the room. As long as I'm not breathing it in, that's all I care about. We have one more here. It's 13 right here. And then we have R14 and 15, which is a 47K resistor. That's the yellow, purple, orange. It's these guys right here. So we have 14. And we have 15. Then the last one, R16, is actually a 0 ohm resistor. This technically isn't really a resistor. I mean, it's more of a link than a resistor. A lot of times they use these in places where you could change the resistor value and put something else there to have the circuit, you know, behave in a different way. So instead of putting a resistor there, they just put this 0 ohm one. I'm not sure why they do that, and I'm not sure why it's like that in this circuit. I haven't actually looked at the schematic in full yet. It's really tiny. Let's see if we can get this in here. For some reason I'm not. Oh, here it is. I'm being blind. It's a little ugly. Let me fix it up. Now there's no gold band on these because there's no tolerance because it's 0 ohms. Alright, I'm just going to unclip this for a second. And they're all kind of just messy in the back here. But what I'm going to do is just pause the video for a second, and I'm going to mush these all down and cut the get ready to cut the leads, and that will be one step closer. And I'm right there. Okay, we're back, and what I did was just bent the leads down close to the board to hold the resistors tight in from the back. And then what I'm going to do is just take my nippy cutters here. I have a pair of diagonal cutters. The tip is really sharp, not sharp, and I don't like them, but I do like these. I'm not sure exactly what they're called, but I like them. So I just kind of grab these from the sides and snip all these leads, and I do save them. These leads are useful. You can use them to make jumpers. Sometimes, like if you were reusing an LED and you just don't have long enough of a lead, you could solder this to the end of it and use that as the lead for the LED. A lot of different uses, but I'm just going to go ahead and clip all of these off. And I'm doing it right at the end of the pad here. And if I need to, I can also push it down closer to the pad. And that'll keep it good. As long as it's holding it in place is what the key is. And I'm also making sure it's not shorting out against another pad. This one's a little close to the board. This takes a little while, obviously. There's a lot, and I'm doing them all at the same time. Now, everyone has their own method. This method works for me. Maybe it won't work for you. Maybe you want to do one at a time. You're getting just started in electronics, and you don't want to go like this. You want to do it a different way. That's fine. You can do it whatever way you want. That's the nice thing about electronics. But I do recommend starting with the smaller components first. It makes it a lot easier to try to get this in now than have to try to get them in later in between some big capacitors or something else that could be kind of dodgy later on. I have a slogan I like to live my life by. It's called, work smarter, not harder. There's a lot of different things we do on a day-to-day basis that if you just stopped and thought about it for a second before you actually just delved into it, you might actually find a better way to do it besides just the brute force way. You know, there's a lot of things in life that, yeah, you do need that brute force, but maybe, like I said, you sit back, you think about it, and go, wait, I got an idea, let's try it this way. And you never know, it might come out a lot easier than how it would have been if you just struggled through it. Like carrying boxes as opposed to using a hand truck is one of those prime examples. Yeah, maybe it takes you 3 minutes to get the hand truck out of the shed you're storing it in, and that's 3 minutes you're not carrying boxes. But if you have enough boxes and you have to make enough trips carrying it, wouldn't it make more sense to, you know, get the hand truck and make 1 or 2 trips instead of 8 or 9 trips, and, you know, whatever. This works smarter, not harder. So in the background, I got my favorite solder and my gun all ready. So I'm going to go ahead and clean the tip. Got my fan in the background, as you can hear. Tip's nice and clean, probably see. And just starting from one here to the other, I'm just going to go around the board and solder all these. And this is, of course, rosin core solder. You want that rosin to come out and clean the area up. Allows that solder to stick. There's some kind of a varnish on this board or something that looks like it has to burn off. It feels kind of sticky when I was handling it before. That's why this isn't quite sticking as quickly as it normally does. Make sure this tip's clean. I do want to get myself a proper soldering station for this desk. This gun's gone, pen I should say, is gone from my shed to here, to my toolbox. I mean, it goes all over the place. And this is actually the second one I've had like this. The first one, unfortunately, I left on over the weekend. And that was after it was left outside at a friend's house for a week. So the thing's been abused. And it just stopped working on me one day. So I can't fault the machine for that. I mean, I put it through hell. I'm not terribly happy with the way these joints are going right now. There's something funky with this board, or maybe it's just the angle I'm looking at it. I can't really tell. But I'm going to continue on the way I'm going right now. Because it is wetting, it is taking. I guess the proof's going to be if it works in the end, right? Luckily, I have my handy solder sucker to the side here, just in case I have to make a fixie. I can just go in and do that. No problems. Oop, I don't want to bridge this over. Now, the one disadvantage about doing this way is you could possibly lose which one you're working on or how many are left, or it's easy to bridge, you know, circuit, you know, solder joints between these. But as long as you're careful, you should be able to just go in here and just solder all these up. So far I'm getting along pretty good here. I know this isn't the most interesting thing to watch, but perhaps to somebody it is. And I appreciate the people who are watching this. Thank you very much for your watching and your time. I'm hoping I'm able to put this at a very, very low level and plug it into the camera and see if it works that way as a microphone. I've read online that you can hook up line level sources into a camera or something with a microphone input, just as long as it's at a low volume. And since this does have a volume output, I think it might work. I think I'm going to guinea pig my computer first, though, before I try my brand new camera, since I don't actually use the microphone jack on my computer. I actually think that's it. Oh, there's a couple more right here I can see. I'm going to have to get a close-up of this board in a second here and see if I can find any more. Clean the tip, rack the gun. See if this camera helps me with this. And I'm not really happy with the solder job on this. I don't know why it came out so blobby like that. It's almost like those pads aren't taking it. Well, let's see what it looks like on the other side. Yeah, the solder didn't really go through it. Good news is I don't see any solder joint bridges, so that's a good sign. There's some of the schmunz on here, which I will clean up later. Yeah. Admittedly, not one of my best solder jobs. But like I said, these are all not, these are all untinned. Oh, I missed one right here. Usually when I do these, they're pre-tinned, which does make a difference. Evidently, at least in my application. So yeah, let me get that last one up there. Just realized I was out of camera. Sorry about that. Okay. I'm going to pause the camera here, and we're going to find out what the next step is. Next step is going to be putting in capacitor C10, which is 100 nanofarads. 104 is the number on the capacitor, which is this guy right here. That's going to go right here in C10. And the leads are going to get bent outwards on that. Hold that in place. And then C11 and C12 are 100 picofarad, which is either 100 or 101. Apparently, according to the instructions, I have two 101s. So I'm going to do that right here in C11. That wants to sit just a little above the board, and I'm gonna let it sit right where it wants. I don't want to squeeze it in and have it bust. And then here's C12 right here. Same thing with that one. Just tighten it in. Let's flip the board over. cut those leads. Now some people like to cut the leads after they solder, some people like to do it before they solder. Sometimes it matters. Evidently some circuits that are built for hospitals or, you know, high-end, you know, kind of things where you don't want them to fail. When you, from what I understand, cut the leads after this is soldered, that becomes a stress point because you've stressed that solder joint up. Whereas if you do that beforehand, there's no stress. That's something I've always done, and then when I read about that, it made sense to me, so I just kept doing it that way. Again, to each their own. If there's no one exact way to do it, then it shouldn't matter as long as the result's the same. Now this is going to be a soldered bridge here because this is actually the same line. Alright, oh, there's one more over here. Okay, next step is installing the resistor. Now resistors are polarity sensitive. There's a couple different ways to tell the polarity on them depending on the resistor. Most of these 3mm and 5mm resistors have a flat side on the base, and that flat side indicates the negative, whereas the rounded side indicates the positive. This one in particular doesn't seem like it has the flat side, at least that I can tell. It's kind of got a weird base on it than the normal one. But what you can tell is one lead is longer than the other. And the longer lead is the positive lead. And that makes that pretty easy too. And the instructions actually have you bending this sideways. So I'm going to use another little handy tool, which is just a pair of flat cutters here, or pliers. And I'm just going to bend this lead back here. Just pulling it up. And a little more, and then I'm just going to bend it like that. I'm going to flip the board over and I'll show you where that goes. Which is this right here. And they have the positive indicated as the open spot here, and then the negatives, the white spot over here, it looks like. So that's going to sit facing sideways in the board like that. Now I actually am going to check this just to make sure that's right. And to do that, I'm going to look at the schematic over here. Here's the LED. So they have the resistor on the ground side. Sometimes people do the resistor on the positive side, sometimes people do the resistor on the negative side. Again, it's one of those things. I've always done it on the positive side. Most of the time when I see these schematics, it's on the negative side. Maybe I'm doing it wrong. I don't know. They work, so I guess it's right. The point is you're trying to limit the current, and you know, traditionally, if you know, current and electricity flows from positive to negative, but in reality it actually flows from negative to positive. So who knows? I don't know which way's right, really, honestly. But I do see that this is the ground, there's the resistor, and there's the LED, and the according to this, we have the resistor going into the negative lead. Negative lead's the shorter one. This is the resistor right here. It works great. So I'm just going to get that in there. Again, we're going to bend these leads. I like to do them in opposite directions too. Cut them. And solder them in. Make sure the tip's clean again. Always do that. And again, this can bridge together because it's the same lead. Alright, let's flip it back over. Now, it's the switch. This is pretty easy. This is actually going to go down here where this guy is, and this can't go in any other way. This just goes in like this. Simple little switch. These leads are going to be a little harder to bend, so I'm going to use this tool. And just try to, doesn't have to be all three, just one of them. Yeah, see? That's what you want. Just try to get that one bent in. I have to readjust my helping hands. And I'm also going to hold that in from the front with my finger as I solder this in, just to steady it a little bit. Once I get one of them soldered in, I don't have to hold it anymore. Okay. Step 5, IC socket. And this is what I'm doing. I'm just following along the steps here. It's interesting that they have you put the microphones in and all that, and then you put in the capacitors and all that last. But we're going to put the IC chip in now. The socket, I should say. And again, it says watch the polarity. You have to make sure this little notch lines up with the notch on the actual silk screen. So when I turn this board over, probably see it right here. Get the shadow out of the way. That's the notch in the IC socket. Here's the notch they're talking about, right in the middle. That actually sits in there pretty nice. I don't need to do anything with the pins. Now these pins could get cut a little closer, I guess, but not necessary. Now with these, what I want to do, this plastic, from experience, melts kind of quick. So I don't want to put a lot of thermal stress on these things. So what I'm going to do is just start with one corner up here. And then do the other corner down here. And then I want to alternate. Now the next step we have is putting in the tabs for the actual microphones to sit in. And these are going to go over here in the ends. And I have to come up with the way to get these in because it looks kind of tricky to keep them straight. They sit in there pretty decent. They kind of wobble around a little bit. So then I got to thinking, why do I have to mount them like that? I know it mounts to the board and it makes it easy, but why can't I put some kind of a, jack there or something? Something to make it a little easier to maybe, I don't know, change those microphones out in case I want to go with a different one or something. So then I started digging around my parts bench and I came up with the solution. And here's the solution. Just put one of these terminals in. I could just pop this in that spot right there, put the microphone in, screw it in, and if I want to change it out, I don't have to unsolder the microphone. That's great, just in case something happens with the microphone, or better yet, I can solder some kind of a lead to it maybe and extend it outward, maybe twist some wires onto it. I can aim them better, give it some better separation. Who knows? That allows me to modify it better. Of course, the question is does this actually fit? Can I just remove these pins and put this in its place? And the answer is surprisingly yes. And it works pretty good. So I'm actually going to do that. I do have two of these. The one thing I am going to do before I do that is just take this out and I'm going to mark. I'm going to call this positive. And on this, I'm going to call this also positive because that's what they have marked over here. You can see one of these is a pin and the other one is a pin in the tab, and this is the pin in the tab. So that's how I'm going to do it, and I'm going to mark this with the same positive. That way I know I got the polarity right in these, because the instruction specifically states watch the polarity. So that's definitely a must with this. And again, I'm just going to mark all these with the same plus. That. I do have a black pen if I want to mark the other ones at negative. I can totally do that too, but that's redundant. I'm just going to pop these guys right in here. Now with them, I actually have to hold these in from the other side, so I'm going to do one of them at a time actually. So let me just leave this to the side here. Take my gun out. I keep calling it a gun. It's not really a gun, it's more of a pen. Let's see, get this in here, hold it with the pinky, hold this here. Now these are kind of beefy, so they take a little bit more heat. Oh. So you got it. There's one. Let's get the other side here. Okay, next step is the electrolytic capacitors, step 8 up here. And again, watch the polarity. I've had these things blow up on me before. Not fun. So you can see what C1 through C4 is, 5 through 7, 8, and 9. So I'm just following that code. These are actually marked right on them, so that's very easy. And let's start with the 1 nanofarad. This guy right here. Now they have negative is marked on these. On the board, they have it marked as positive. Just like LEDs, the long lead is the positive, the short lead is the negative. So let's put this in C1, which is you can see why you want to put these components in now, not before. That's right here. And the leads. Also cut it since I'm here. I need another one for C2. Which is down here. Bend the leads. Make sure that's right. Another one. This is going over at C3, which is up here. And then lastly, C4, which hopefully this doesn't become C4 and blow up all over the place when I plug the batteries in. C4 is right here. Cut the leads. I think I found a resistor I missed before. Sorry, a little close to the camera there, out of focus. Again, this is my first attempt at putting one of these together on camera. So bear with the minor nuances of this project and endeavor. Oh. That's a little solder sucker. Do it over. This one's kind of ugly right here. Okay, let's do this again. Okay. We still have more. We have 5 through 7, which is the 470s. Those are the big ones. They really go bang. Okay, we got those in the spots. bending leads. Soldering time. Oh, and look what I just did. I didn't cut the leads. I can't get in there. Okay, good as new. Oh, a little bit of a connection here. Sometimes you could just run the tip through it and it will clean it up. Now, there's 2 more capacitors left. And these are the 10 nanofarads. They go in, of course, the last 2 spots, which are 8 and 9. And they look like they're actually back to back. Tip. Now we have the phono jack, which can obviously only go in one spot, right up here. Now I'm going to use one of those tabs to hold it down, the front here, and see if I could push one down the back too. I'm going to do the same alternating trick with this. Oh, I gotta fix my stand here. I'm going to start with the bottom tab. And go to the back tab. Back to the front. And the back. And then the middle. We're at step 10, the potentiometer. This is a 50K. And this is going to be a stereo pop because it's got, you know, leads in the front and the back. You have it in and out in the ground, basically the wiper. So this is just going to sit in the end over here. Just bend some of the tabs down, hold them in place. Clean the tip. And solder away. Now, one of the things I am doing is I'm putting this in the front of this pin here, putting this solder on there, and then I'm putting the solder on the back of the pin and allowing it to flow around to the front so it finds the heat. And here's actually a couple ones over here that I forgot to do on the other side. So I'll just hit those up now. Now we're on to the step 11, which is actually mounting the chip, followed by putting the battery holder on, which is going to be the last bit of soldering. Now I was thinking, since there are pads here, could you put this here, hold it in with the nut, and solder it on? But it's not really necessary, so I'm not going to bother with it. Also, there's another couple pairs at the top. I will, of course, give this board a once over before I do connect the batteries to it. Now we flip the board over. And let's put the IC in. This just comes out of the static proof packaging. Now there's no notch, but there is the dot. And I think the dot is what's going to indicate the polarity there. The notch is at the top there. Right up there. So we'll just stick this chip right in that socket. Now, if you look at this, these pins are kind of splayed outwards, and that's the way they sit in the tubes that they ship in. If you actually just take this and put it on the surface and like rock it backwards, and then flip it over and rock it the other way, it pushes all those pins inward more, and it makes it easier to install in these sockets or into the actual PCB itself. Now I like the sockets for two different reasons. One, of course, there's no heat getting affected, you know, there's no heat going into the IC. And two, you can replace it. They're a pain in the ass to kind of have to unsolder sometimes. If I can get this in here and get it on camera, that'd be great. Make sure all the pins are right. Let's go in more on this side. Hang on a second. That's more like it. And that's actually all the components, and just like that, this thing's put together. Again, minus the battery box, which we're going to put on the other side, and we have to put the, you know, the antennas in these little custom holders that we put on this thing. So let's look at them for a second. So there is a little tab on here, and according to the diagram, let's see if I can. This actually sits around there, and having it this way, they're not exactly going to reach. So what I'm going to do is take the pieces that it gave you, and I'm going to solder them onto here, off camera. And that should do. Now I do have to find a way to hold these on here, like physically. So I'm thinking about just taking these leads and bending them, curving it around. I might want to do the pointing in this way because that'll keep that. Or I could use some of these leads that I cut off of the resistors and stuff. So I could just stick that somewhere in here and see what I can come up with. And here's the solution I came up with. I decided to just solder 2 solid core wires, I think these are 22 gauge wires, to the leads, and just a simple like hook kind of a configuration where the wires are just hooked around each other and just tightened up. And I'm going to apply solder to those, and I'm also going to slide some heat shrink tubing down here, and I'm going to shrink this just to make it nice and neat. And then what I'll do is I'm going to cut a section of this wire, and I'm going to twist them together to make it nice and rigid, tin the ends of it, and that way I'll stick those in. Also, I was calling the one with the extra tab positive. This is actually negative. I wasn't sure what the polarity was on it, so I just had to pick one and go with it the whole way through. But this isn't actually, this is indeed negative, and that tab's actually shorted out to this case, I believe, inside. So I fixed that. Also, I have a black wire going here and a green one here, and I remarked the board appropriately, just to keep it consistent and correct. So coming in here, cleaning the tip, and just gonna go right up and solder this through. Especially want to make sure I have a good connection with that ground tab. And I want to make sure I have enough on there to really hold this. Like I said, this is going to be done with heat shrink tubing, so that'll hold that and cover it nice. And I don't need a lot of room. In fact, the more room you have, the more like an antenna it comes. So I'm going to try to keep them short, but I do want to keep it, you know, more I can point these out. So right over here is where I'm going to cut it. And that's the lead we have left. Let me put some shrink on this, and I'll come back to you. And here's the final result. I have the leads twisted up. I have heat shrink on the end of it to keep it nice and snug. And then this is just going to simply insert into the board like this, and it will allow me to position this in different ways, or perhaps put this in a case better. Because that's the thing about this. The back end is one thing. You know, you can make a case with this, you know, even though the jack's on the side, you can make a case with this. Not terribly hard, but putting them with the microphones the way they had them mounted on this board, I didn't like that. Plus I can do the whole cross thing and put the microphone, this microphone, from that side over here, and, you know, position them a little better, I think. So I'm glad I did that mod. Now I gotta do the other side. And here's the final result. I put some red heat shrink on one that's going to be for right, and black that's going to be the one for left. Also, the polarity is marked with green on positive and black on negative. This way I have the wiring inside will allow me to bend these and actually put them into like a cross configuration or any way I want. So they should work pretty nicely. I'm going to fit those in and get some, put the battery box, get that ready to put on and see how this works. This is one of those connections that's best made using multiple fingers. So I'm going to hold the wires in with my fingers like that, and I'm going to use the other fingers for the solder here. Sometimes you have to do it this way. It's the easiest way. There's no other way to hold it. Especially when you have a couple things you're trying to hold at once. There we go. I left the leads long just in case I wanted to put this next to this in a box instead of underneath it. I suppose you could also put longer standoffs on and go the other way. But again, options. So I'm going to get this routed and I'm going to attach this box. And voila! Battery box is mounted. Everything's done. Now it's just a matter of putting the batteries in it and making sure the magic smoke doesn't come out of the capacitors. Or the IC for that matter. Got two of them, one rolled away on me. Here it is. Of course, I don't know which way the power switch is, so let's make sure the light doesn't come on. Okay, the light didn't come on, so that's a good thing or a bad thing depending on which way this is set. So if I switch this the other way, hopefully the light comes on and it doesn't blow up. Yay! The light came on. It didn't blow up. Great. There's one thing I got to do now. Is put the microphones on and hook the headphone up to it and see what happens. And there you have it. This is the final project. Done, done, done. Turn it on, still didn't blow up. Looks great. Now I just have to plug those headphones in and give it a shot. Well, womp womp. I plug it in, light comes on, I get no sound. Something's not right. Maybe this isn't any good. I don't know. But it's late. Something I'll have to come back to tomorrow. We'll see what happens. Goodbye for now. Well, I never cease to amaze myself. So, when I put this together and I initially shot all the footage of this video, it was pretty late at night. I was kind of tired. And for some unbeknownst reason, I started messing up a lot. I put resistors in the wrong spots. One of the... actually, it was this microphone right here. I didn't solder one of the tabs right. So when I started diagnosing it, I found out first. Still didn't work. So then I tried looking at the resistors, making sure they're right, and sure enough I found out that I swapped them. I think it was actually this one and this one with these two over here. I don't know how I did that. I went ahead and fixed them, and then of course I tested it out and it still didn't work, and I was still going, what the heck, why is this not working? Come to find out, I didn't actually solder two of them in. Yeah, it was late, I was tired, so I kind of gave up on it. Looked at it the next day and I figured out my mistakes right away. I knew what they were. It was pretty clear. So looking at it, fixed it, went back into footage, laughed at myself as you probably did watching it. Some bumbling mistakes, calling the LED resistors. Why I did that I don't know. Kept calling the microphone's antenna. Why I did that I didn't know. I did mention that the longer the wire was, the more it became like an antenna, meaning that it would pick up outside noise or interference or something like that, but you need quite long wire to do that, I would believe, and this wouldn't have that problem. But the good news is I did fix it. I put everything together and I plugged the headphones in and it worked like a champ. Now I did want to try this out by plugging this into the camera's microphone jack, which technically this isn't a microphone output, it's a headphone output on that board. You can do it, it does work, but it's so sensitive. I mean, even at a low volume, it's very, very sensitive. I mean, you could pick up the slightest thing, like the fan in the room, everything. It's very, very sensitive, which is good. It's what it's designed for. But it really works well. Now, they said you could use it for listening to TV in a room. I see how that works. You know, you could put it on the couch next to you and, you know, turn up the volume on it, turn the TV volume down so you're not disturbing the others in the room, and it would work, and it does work. But it amplifies all the noises in the room. So even if it's, you know, your partner sitting next to you, you know, breathing heavy, you can hear that too. You have the air conditioning going, a fan going, you know, like I said, your partner next to you, and the TV on in the room, and you're trying to hear the TV louder. Might not work the way you think it is, unless you have like a longer lead on it, and you could put this closer to the microphone, to the TV, so it picks it up better. That may work, but for the intended purpose that they advertise it for, I don't think it's going to work as well. Now, what it does work for is just, like I said, amplifying all the noises in the room. So if you do have a quiet situation where you're trying to pick up, you know, something, you know, quiet, somebody whispering, let's say, you know, if you're trying to hear something, eavesdropping, I guess would probably be the best example of it. Or if I use it outside, it was just, you know, crickets. You heard crickets and birds chirping. It was nothing going on. It was a dead night, you know. But I plugged these things in and I turned the volume up, and it's amazing how much it amplified just the slightest little noise of the crickets in the background. And to make it even more fun, I actually used soundproof headphones that I used to use in a recording studio that, you know, cuts like 29 decibels out, which is, you know, most of the background noise easily on a quiet night. So with those headphones on, you heard nothing until you turned the volume up, and then you heard everything very loudly, and it was pretty cool. And yeah, once you turned them off, it was like you heard nothing again. It was two totally different extremes. But I'm gonna test it out. You know, I had a situation where I went camping a few weekends ago now, and the trip was cool because it was on the water, and there was a band playing at a beach club on the water, like on the edge of the water. And when we had to get on a boat and cross to an island in the middle of this lake, and we can hear vaguely the band playing on this beach club. And it would have been cool to have this because we could have, you know, dialed it in a little bit, and I guess, and picked up the band a little bit more and tried it out to see how well it would have worked across the water. I have a feeling it would have worked really well. But yeah, I'm happy with the build. I mean, it came along actually better than I thought it did. I looked at the solder joints again, and it was just the light I was looking at it in and the way the camera picked it up. But they are very solid joints, even the ones I had to go back in and repair. I mean, I did have one problem with the solder pad lifting up on me, and I expected that. You know, that happens sometimes with some of the cheaper made, you know, PCBs where they don't have a lot of copper down, but that's okay. The lead I had on the resistor I replaced was long enough that I could bridge over to another connection. And I've done that before. You have to, you know, follow out the traces on it, make sure you're connecting it to the right place. But all in all, like I said, I'm very happy with the build. I'm going to try to put this into some kind of a case. I should have a follow-up video if that ever happens. And if you like what you saw, just hit the subscribe button. There'll be more videos in the future. And if you have any suggestions of how I can improve these videos, leave them in the comments below. I am open to all suggestions and all constructive criticisms. I know I'm not the best at these videos. I'm trying hard to make them entertaining and not boring, and also informative. Hopefully on future ones I won't have any more blunders like calling the LED a resistor. Jeez. Yeah, gee, I have nothing to say about that. It must have been really, really late, and I was really, really tired. That's the only excuse I could make. But anyway, that's all for now. Take care.